so bad. How's it going, everybody? Feel free to jump in. Check this out. Bam. We need to fix that. Let's YouTube Race Studio. This. Hey, Hollywood. There's the link for you. Jump in. Not bad, right? Let's I've been cleaning up the desk a little bit, John. I've been trying to tuberize around here. Yeah, I guess it does look totally different, doesn't it? Where's my logo? Oh, my logo's locked. There we go. Bam. Don't know what I was doing. What was I doing? I was going to the studio looking at content. And it doesn't show it. I don't care. 2 shits I give about a thumbnail. I'll fix it later. I'll fix it later. I do have something I do want to tear apart on stream for you guys. Look at this thing. Let's go to that eye in the sky. This thing. Ugh. Oh. The Vista 3-R. Oh, lordy. This thing's going to be fun to take apart. I don't even know if I can take it apart. That right there. I'm so proud. Made in USA. There he is. Hey, buddy. How you doing, Hollywood?
Am I here?
Oh, you're here. You're live and on.
You hear me okay?
Oh, excellent. You hear me?
Yeah. Oh, yeah.
All right. So, what you been up to, Hollywood?
A little bit of this and a lot of that. Very specific.
Can't. I knew I wasn't going to get away easy. They've riveted it shut, and I don't want to put a bunch of shavings over my desk tonight. Not tonight.
What you got there? Power supply?
Yeah, this thing. I don't know if it's even worth its weight, but it was the Motorola transistor regulator, I guess, right here on the back. Really got my attention.
Mm-hmm.
The output here, on the other hand, couldn't be any worse. I wonder if this thing got really wet or something. You can tell it probably got rained on pretty good. I just love this cracked paint. Was this just not on everything? Like when you were a teenager?
In the 50s and 60s, it was. Yeah.
That's beautiful.
Yep.
I love it.
Hides a multitude of sins.
Oh, it's great, isn't it? It's like what did they? So my house is like 100 some years old, and there's actually 2 layers. So there's like the concrete layer wall, and then like they've put up board on top of that wall since then, and then they couldn't make any of that line up. So then they put knockdown on the walls everywhere.
Exactly. Yeah, you're right, Chris. It's a patina. Yeah.
Oh, hey, Chris. Anyway, enough of this. Clifford Industries. Boy, they were proud of this thing too. They even like put a little lip across the top here.
You know, if somebody was smart, they would do their car the same way with that textured paint.
Oh, for the air resistance? Is that what you're getting on?
No, just for lack of, you don't have to wash it, you don't have to wax it. Buff right out. You get a scratch in it, you just paint over it with a paintbrush, and you're good to go.
So it has a Motorola 207 7626. Let's see. 207 7626. 7626 comes up with a not a lot.
NPN?
What? Let's see. Maybe there's not a dash. Maybe this is a run-on number. It's a run-on number. Okay.
Try 2SC 7626.
2SC. Oh, nope. 2 Sierra Charlie?
Yeah.
NPN transistor. I don't see the 7626, however.
Is it in a TO3 case? What you're looking at online? The 2SC number?
Let me middle screen splaining. Oh my, I've lost my middle. Oh no. It's all messed up now. I'm sorry. I've flopped my monitors around, so now my OBS is all messed up. Door dings don't show up. All right. So were you talking about the package of it?
Yeah. Yeah.
Okay. I don't know. I don't know what the package is. Do you not? You can see that, right?
Yeah. Yeah. Yeah.
Okay.
That's a TO3 that you have physically in front of you. What I was wondering is when you looked it up online as a 2SC, does it come up as a TO3 package? If it does, then that's the unit that you have in front of you.
Okay. TO3 package. TO3 2SC 76. Oh my lord. Oh, there it is. You're right. It's a TO3 package. Look at you.
Mm-hmm.
Let's look at some specs on this. Let's fix middle screen splaining real quick here.
I'm going to guess it's a 10 amp, maybe a 15 amp, but probably a 10 just based on the size of the power supply. This is probably a 5 amp supply.
A 5 amp? I could go with 5 amps. That seems like a lot of amps.
Yeah, it's a CB power supply, or what you would use for a scanner, or it's small.
Yeah,
and that's perfectly fine. And so the engineers, whoever built it, they wouldn't put a 40 amp transistor in it. It would be cost prohibitive.
So I guess we're seeing middle screen splaining now. So we were the 7626 where they go on for days. 7626. NPN silicon 5 ampere. Look at you.
Uh-huh.
Oh man. Oh, you can buy them from this guy right now for $5. Look at that.
Yeah.
So it comes up.
Back in the good old days when we had Radio Shack, they were right there on the wall.
You could just pick one off. Huh? I've got let's search Google for that. No, it kind of blows that out of the water. Yeah, we're off track a little bit. What did I want to show you? Do I still have it to show you? I do. You're going to love this. I don't know if I remember showing you last time, But look what I found.
Organ music for suspense.
Do you see this?
Oh, I got it. Yeah. Nice.
Wonder how much this retailed for. I bet you it was $4.
Yeah, it's about $4, right? Right. But new in the package, you're right, John. If you sell that on eBay in a couple of years, it'll go for $35.
Oh man, that is too funny. 5 amps. Yeah, that is all you need. So 5 amps at let's see. Wait, no, not today. There it is. Wow, the calculator actually takes time these days to load up. What do you think that thing's set at? About 13 volts or 13.8 on the nose?
Yeah.
So we're calling it a 69 watt power supply.
Yeah, and it may not be adjustable,
Sure.
just
Yeah.
a Zener diode.
Okay. Yeah, it might be worth it. It sure does weigh a lot. My word, it's probably got a big old hunkin' transformer in there.
Yeah,
That
it's got
probably gets,
real iron in it. Yeah.
this thing weighs a ton. Oh. So the loop, I want to thank you for keeping me out of the rabbit hole.
Oh, sure. Yeah.
Because I thought for sure I should be able to hear 160.
Right.
But no.
Yeah.
No, when I scan it, there was an 8 ohm load presented at 160.
Exactly right.
Holy cow! An 8 ohm. Like I have to try to make something that is that much of a dead short.
You can. Is that the objective? Is you want to use something for 160?
No, not honestly. I thought it would be best.
I'm not judging. Just
I've caught wind that 160 where I live is not really a thing.
I'm surprised.
Is that right?
Yeah. Yeah, because it should be a thing across the country.
I was told it was a Midwest thing, not really a peninsula thing.
No. It's very active up here in the Northeast. So if it can happen here, it can happen anywhere.
I have to agree with that for sure.
Yeah.
Well,
you could try opening once. Is the loop still up?
Oh yeah, absolutely.
Try feeding just the center pin on the coax.
And then
just in other words, so take a tuner, radio into the tuner.
I know what you mean. You want me to quarter wave feed it?
Yeah. And then ground the tuner. Flip lead the tuner to the neutral wire on your AC or your, if you have baseboard heat, forced hot water, clip it on there.
Oh, I'm in Florida.
Yeah,
there'll be no baseboard.
No baseboard heat where we live. Okay. What's the temp down there, by the way? Because it's chilly here.
Everybody's driving kind of crazy right now. My buddy Wes is showing me this picture. I guess this is his work vehicle. And what he's encountering right now, which is pretty impressive. Oh my, that's too much for me.
Jim was showing snow.
Was he?
Yeah. Same type of thing. So that they're all having a blast down there, learning how to drive.
They were talking about shutting bridges down. Yeah.
It's interesting because if you go to Vermont, let's say, and they get 10 inches of snow, they don't even report it. It's not even on the news. It's what do you do? If you get 2 feet, then they report it.
Well, they've gone and shut down the damn schools tomorrow, and tomorrow and tomorrow is a day that she has to work at the hospital, and so therefore it's my day off. So I will hear about this tomorrow.
You get to play it with antennas tomorrow.
Oh man, I get to. Well, I've got to. So of course I didn't factor in velocity factor when I put the loop up.
It doesn't matter. Don't worry
Right.
about it.
Yeah.
At 160, it's so forgiving. Just the longer the wire, the better, pretty much.
Well, it's an 80 loop at the moment. It's not a 160 loop.
So that's a quarter wave at 160.
Correct.
Excuse me. I'm going to take that back. It's a half wave long. It is a half wave loop.
You're right.
Right? So it's a half wave at 160. So it's going to be very high impedance. You won't need much of a counterpoise at all.
No.
But you do need a good tuner because it's going to be about 2,000 ohms.
It sounds to me. Yeah.
How long is the coax between the loop and your shack? Roughly 50 feet, 100 feet, 20 feet?
Hold on. I'm thinking. It's about getting close to about 250, maybe 300 feet.
300 feet away?
Yeah.
That's a long run. Wow. Okay.
Yeah. So check it out, right? So the first part about getting out to the field is the field run. And I've actually got that on LMR 400 that I've buried into the ground.
Okay.
And then that comes up to a pop-out box. And then out there in the field, I have, so I've got big pulleys. And my loop can actually, I don't know if I told you, but it can spin within itself.
Okay.
So I can change the feed point impedance. And so I've got this long feeder that kind of doubles up because it swings all the way to this corner and it goes all the way back to this corner.
Got it. Yep.
So I go out there and I just kind of, run around with it. But yeah, the whole damn thing, it spins. And I would like to think that I've got this infinitely adjustable, multi-banded, aimable loop out in the backfield, which is it's almost like having too much all at once.
So at 160, it's a cloud burner.
Very much.
Because it's just you can't get them, 400 feet up in the air. Nobody can.
No.
So a horizontal loop at 160 is going to, it's just going to feed out and it's going to couple to the ground and half the power goes in the ground. But don't worry about it. Don't worry about it. Just do it. What I would do, I didn't realize you had that much line between the shack and the field.
Oh, it's awful, isn't it?
So connect your coax in the shack the normal way, and then out in the field, how long is the jumper between where it comes out of the ground and where it feeds the loop?
That is a tuned piece of 75 ohm at 120 feet, so that it hits 50 ohms every harmonic that we're after.
Okay. So, all right. So that's fine for 80. But if you wanted to do 160,
it would be on the inverse.
Right.
Which is fine because I think I'm getting presentations of like somewhere in between. I don't know where it's at. It's in between like 20 ohms and like all the way up. I think is the most I've seen is like 400 ohms maybe, or maybe a little less.
So what I would do to feed it with 160 is I would go through the ground the normal way, have your 75 ohm stub, if you would, from the ground up to the loop, and then where it meets the loop, disconnect the shield. So you're just feeding the loop against the shield
coax
of the coax.
Right.
Correct.
Right. So I could put in a ground lift switch.
Yep.
Yeah. Let's do that.
Yep.
Ground lift switch.
Even better if you can put the tuner out in the field.
You know what? I've got a tuner I don't care for that much.
Okay. Yep.
I'll put it in some Tupperware.
Yep. A lot of people that run 160 do precisely that. They put an auto tuner or a manual tuner. They set it for one frequency that they like, and then they stick it in Tupperware, and that's that.
The hardcore guys make the permanent. I guess what is that? I guess that would be an L match, right? An
You
L
can do an
circuit.
L, you can do a pi, you can
Yeah.
do a T. It doesn't matter.
Now, what was? I don't know enough about this pi circuit. It's the
Okay.
2 capacitor one, right?
So yeah, so it's just the way it's laid out. A T and a pi can both have 2 capacitors and 1 inductor, or they can have 2 inductors and 1 capacitor. It depends on whether you want it to attenuate harmonics, so we'd call that a low pass filter, or whether you want it to attenuate low frequencies, and that would be a high pass filter. And you would use that if you had an AM broadcaster a couple of miles down the street. You want to attenuate him, but hear shortwave. So you want a high pass.
Simple high pass LC circuit. Let's see how we get blasted here.
Yeah. That's a pi network. Yep.
In either a pi or a T. As it suggests by the name, the basic pi network element has 1 series capacitor, and either side of it there's an inductor. All right, so we've got inductor on either side. There's an inductor connected to ground. Here's our ground run. Got it. Further network elements can be cascaded if a faster roll-off rate is required. Okay, got it. So this is a very kind of high Q tuner, is what we're...
No, not necessarily. It's
No.
a pi network is what you always see on the output of a linear amplifier. It's just a tuner. It's a seesaw. All tuners are think of them as a seesaw. It's matching one impedance on the input to a different impedance on the output.
I can follow that.
And if the capacitors are in line with the hot lead, if they're in series with it, that's a high pass. So the high frequency, remember, high frequencies like to go through capacitors very easily. Capacitors block low frequencies and they block DC. So that should be obvious too. That's a clue. If you look at a capacitor and you go, well, I know it's going to block, DC can't go through it. So take it one step further and say, yeah, low frequencies it doesn't like, but high frequencies it zips right through, no problem. So it's passing highs. It's a high pass. If you put an inductor there in series, it's the opposite. An inductor passes DC, no problem, but high frequencies and RF it doesn't like. So that's a low pass.
Frequency response of a first order high pass filter.
Mm-hmm.
We have a stop area. This is like pretty much our minimum of our roll on to where this happens. Okay. So they call the pass band is also the bandwidth.
Yes.
Got it. Okay. Phase.
And
I want to get in.
Everything is adjustable. Yeah.
I want to get into phase. Pretty good because I was asking some questions, and apparently you can have something that looks beautiful on a Smith chart, but then the phase is wrong.
Right.
And so that has now really upset me.
Yeah, it's a bit of a Rubik's Cube. There's a lot of moving parts. I'll make this analogy with audio. So if we think of a home stereo system and it has an equalizer on it, 5-band equalizer, let's say. You can use mediocre speakers, smaller than what would normally you'd like, and you bump the bass up with the equalizer, and it's compensating. That's kind of like what the antenna tuner is doing. It's pushing certain frequency bands into a load, that would be the speaker, that the speaker wouldn't normally be able to reproduce. So you can push some lows into it and get a little bit more bass out of it. Okay. But what you can't do is you can't change, not easily anyway, you can't change the phase angle of that speaker. Now we're talking about psychoacoustic stuff. We're talking about, when I sit in my easy chair and I have the two speakers, I'm getting bass out of them now because I've got the equalizer turned up. But guess what? Now the singer's voice is not, if I close my eyes, I can see the person singing in front of me, but guess what? Their head is 10 feet wide. It's not 2 feet wide or a foot wide like it should be. So I've lost the focus. And that's because of the phase, because I'm adding bass to it, but I'm changing the phase. It's the point is it's a moving target. It's really tough to do correctly.
I analyzed an antenna recently, and it's a banger antenna, but at the same time, my rig expert was telling me, I think that might be the picture right there. It was telling me that the phase was like 112 degrees out of phase with with them between the voltage and the current.
Mm-hmm.
And I thought to myself, that is really far apart.
Mm-hmm.
So I mean, like,
when the load is a pure resistance, then the phase is zero between current and voltage. Have you ever heard the term Eli the Iceman?
No.
Okay. So ELI. This is a little bit of poetry that it probably came from the military way back when. But back when, before refrigeration, and we had the Iceman, would drop off a load of ice that you put in the right in your refrigerator because you didn't have an electric refrigerator.
Yeah.
Right. Okay. So his name was Eli. So Eli the Iceman. So if you look at that sentence, ELI, E is voltage, I is current from Ohm's law, and L is an inductor. So ELI. Ice is I, which is current, C is a capacitor, and E is voltage. So it's the inverse. When it's a capacitor, they're in the opposite order. And when it's an inductor, Eli, then E leads before current. So if you put an inductor, if you put an alternating signal through an inductor, the current lags the voltage. Voltage first through the inductor and then the current.
Okay.
And if it's a capacitor, it's current first and then voltage. And its maximum is 90 degrees between those two, the current and the voltage. Maximum. That's a perfect capacitor and a perfect inductor that doesn't exist, only in textbooks.
Right.
Okay, but that's 90 degrees. And you can make, capacitors and inductors in parallel and in series and this and that, and you can change the phase angle. You can chase it. But that's where that sentence comes from.
That's a great way to remember that.
Mm-hmm.
Let's see. I've since dumped YouTube Premium, but as a content creator, it's kind of hard to do such a thing.
And this is really what your antenna tuner is doing. It's chasing let's say the bottom picture there where you've got a delay between current and voltage. That would be at the antenna end. And the top one, they overlap, and that's because of the tuner. You're adjusting them so that they overlap each other, and now there's just resistance there. And that's what your transmitter wants to see. 50 ohms, J0. No inductive reactance, no capacitive reactance, just 50 ohms pure.
Like you're
And that's
pumping
how the
into
tuner
a
does
damn
it.
pumping into a damn resistor. Okay, so it
Yeah,
pulls the
yeah.
the current and the voltage back to null.
Right.
Hmm.
So in transmitters, ham radio, we call this SWR, standing wave ratio, or voltage standing wave ratio for the engineers in
If
the
you want to
crowd.
be
Okay?
cheeky, yeah.
Yeah. But
Uh,
in AC power, if you're an electrician, it's the same thing. They just call it something different. They call it power factor. But it's the exact same thing.
PF.
Yeah. It's SWR.
Point and click, grabbing on the wrong stuff here. All right, we've gone further. All right, show us what you got. So there's that magical 90 degrees that you were talking about that doesn't exist. Yeah.
Mm-hmm.
Now that's what you would want to see presented to you at your analyzer from your antenna. Is a 90 degrees out of phase?
No, you actually no, you want to see zero.
Oh, you'd want a pure resistive.
That's what the transmitter
zero
wants to see
phase.
zero. That's the goal.
Okay, I
Yeah.
gotcha. Okay, so it's when we're slightly lagging one to the other is when we
That's
when
right.
we get our standing wave.
That's right.
Okay. Well,
Yeah, so Chris says he learned about Eli the Iceman 30 years ago in engineering school. Right on.
oh,
Yep.
that's great. So it looks like inductive, you said, is when current. Are we current here in blue?
Yeah, so see, I hate the math part of it. I used to teach this stuff, but I still hate the math part.
We don't.
Just think of the name Eli.
So let's go back to that.
Yeah. Keep it simple.
All right. Capacitive.
Yeah, so
inductive, capacitive, voltage.
Yep.
Okay. I'll have to let that sink in, right?
Yeah. Yep. But once it does, you'll never forget it, you know?
That'll be great.
Yeah.
The Book of Eli. Oh, hey, there's Prepham. Nice.
Yay.
Yay. I graduated and move on, Chris says. Got there and got out. That's great. So so I showed you I didn't get a chance to show you a picture of this. Let's go PHO. The loop in the background, right? Did I send you or email you like kind of
you sent me a picture, yes, through the email. But if you want to put it up on the stream, go for it. Yeah.
Yeah. Let's try. Middle screen explaining. All right, so up is north. And so my house is somewhere way over here. But anyway, my feed line comes and it pops out right around here. And then I've got 120 feet that run here and then kind of run back because the center is where it wants to live mostly, the feed line, because I can run out to this corner, which is the lower corner, and I can spin this whole damn thing. And my feed point will move from here and it'll go all the way over to here. Now, if we move it back to here, science tells me that the direction of this antenna would be firing this direction. Is that right? From the feed point onward?
Okay, so
I mean, there's 4 lobes, and then we have to also be talking about the frequency or the fundamental of whatever we're talking about as well. So I say on the main fundamental of 80.
So it's been my experience that if you have a loop, it doesn't matter so much where you feed it. If it's horizontal, if it's vertical, it makes a difference, especially with the load that it sees into the coax. Chris says almost correct. Go ahead, Chris. What do you mean?
Go ahead, Chris. Help us out here. Jump in here. There's a link at the top of the chat. We'll wait for Chris.
Yeah.
I won't even.
Ziggy, do you have a copy of MMANA Gal?
Mamana Gal. I don't know if it's on this computer, but I can get it real fast.
Yeah.
Yeah.
Because that you can model and put on there and spin it around, and it'll show you, where the lobes are going to go.
Oh man,
it's not perfect, but it'll put you in the ballpark.
I've been Mamana Gal. So this is funny, right? I just quickly tried to Google this, and somehow I just knee-jerked clicked on Mamana Gal. This is some kind of Christian vampire. That's pretty great. I'm not even kidding right now. This is great. Christian vampire. The name also originates from the expression used for a severed torso. Mamana.
Be careful what you download.
I'm telling Mamana Gal. It's right there. It's described as a scary, often hideous, usually depicted as female, and always capable of severing its upper torso with. Anyway.
So this is good. So Paul says he's got to figure out how to use the software. So this would be a good time to put it on the screen. And
Chris we're going to start from scratch. Yeah.
Oh hell yeah, yeah.
MMANA.
And Chris says if you feed the corn, it'll be certainly directional. I agree. It does move around. You can walk it around. There are many lobes usually, not just one or two, like on a dipole. So, and there's more lobes depending on the, go easy there. Be careful what you click on.
I was waiting for it. Not secure, boy. You know where that's been? Nobody knows where that's been. I thought we were above version 3.5. Is that the latest version by 2020? Yeah, that's it. And then we can get pro now because it's all
I didn't know there was a pro.
Yeah, so it's all abandonware now.
You may be looking at different software. Are you looking at Easy, Nick?
Am I?
Yeah, you want MMANA -gal _basic.
I thought they gave away the pro version because...
no, I think you've got it confused with a different piece of software. Just humor me for a moment. Let's just do this one, because it's really easy to use. And then if you want to go from there, once you get a hang on that, then you can do the Easy, Nick.
Mamana Gal Basic. Here you go.
Yeah.
So, same website.
Okay.
Yeah. I thought I could be wrong, but I thought that they were giving away the pro version.
It's Easy, Nick. Yeah, that's the pro one. Yeah.
Okay. All right, let's get our basic stuff.
Yep.
I thought that the pro one was free now.
It is free, but it's a more complicated piece of software to use.
Yeah.
So start with the basic stuff first.
Boy, don't you miss standalone EXEs? Not for that reason. Remember, you could just slap it on a floppy and just...
Mm-hmm. Those floppies are long gone. Long gone.
Dating myself a little bit.
Yeah, we used to get the floppy puncher.
Every time
Go from a 360 to a 1.4. Just by putting a little
It's pretty
cut.
slick.
Yep.
Keep your fingers crossed.
Mm-hmm.
All right, let's see. Dang, error correction. All right, I'm missing a few. I'm missing some chat here. Let's see. Paul and Chris. Did Chris help us out here? Let's see. I found the feed from the center, so I didn't make recording expected. Okay, he's talking
Chris,
about.
you're holding on to the old routers because you've got the same problem I have. They might be worth millions someday.
You know, I was cleaning out the shack the other day, and I think I organized like probably a stack of 7 of them. Like I was trying to figure out how to keep them all like lined up,
right,
and in one place. But all right, so I've double clicked on an application here. Oh boy! Oh, hold on. We need a call sign.
I don't remember any of that.
I was just kidding. I don't care who sees my call sign.
No, but I don't remember ever installing the software and asking for a call sign.
Well, I guess it's got pronouns too. I don't know.
What?
All right, so
Yeah,
Z's
okay, that looks legit. Okay, all right.
Z is always up, and I know that there's probably some fun stuff in here. What do we got here? All right, what were we talking about? We were talking about loops, so let's go maybe receive loops, LBEV. No, I don't see any LBEV. LBEV?
No.
Beams, feeders, matched phase, short. Stacks VHF beams. Not a whole lot going on in our. I'll have to download some.
How about if we just draw one?
You want to draw one?
Yeah.
All right. So we need. Are we going to do the triangle? Or are we just going to do 4 sides?
You can do a triangle. No problem.
Oh boy.
I'm going to make you full screen so I can follow along because it's really small on my my screen here. So sorry, chat.
Yeah, right. See you guys.
Okay.
All right.
So so go up to the top. You'll see there's a picture of a. I got to. You know what? I've got to bring up mine because I can't see it. There's the title of the show is covering the top row of icons on my screen as I'm looking at it. Yeah, go one to the right. Yep. Oop.
The title of the show. Are you talking about this logo thing?
No. Don't worry about it. It's okay.
All right.
The icons at the top.
Yeah.
One of them is the drawing tool.
Make a stack. Element edit. Is that not the drawing tool?
No.
Okay.
It's not. If you go on the right-hand side, it's 1, 2, 3. The third one in. No. Get rid of that. Close that one. To the left. One to the left of where you were. Hold the mouse still. You see the word far field plots?
I do.
Okay. The D in field goes straight up.
Antenna definition edit.
Yeah, click on that.
Okay.
There you go. That's how you draw them.
Okay. Antenna definition edit, not element. Antenna definition edit. Okay.
Wait a minute. What are we doing here? No.
By Ziggy. Okay. Source. This is basically.
I think you've gone click happy on me. You're just clicking on everything, and that's okay.
I have to remember that there's just a few seconds of delay in between.
Yeah.
In between.
Yeah, I'm hearing you in real time, but the video that I'm watching is way delayed.
Yeah, sorry.
That's not your fault. And
did you want me to stay here on antenna definition edit?
Antenna definition edit. Close that.
Okay. Element edit. I usually always start with the element edit. Number 1 wire, base element.
Okay, so it's not element edit. Close that one too.
All right.
Let me, you know what? Let me bring up my version of the software because I don't know. I just do it from muscle memory. I don't even read what the thing is called. Yeah, okay, if you go to you see the word far field plot?
Yeah.
At the top? Okay.
Uh-huh.
If you go to the D in the word field and go straight up, there is an icon there that if you hover over it, it says wire edit.
Got it. Hey,
Click
look at
on
that.
That's the one you want.
All right.
Okay.
New wire.
Great. That's the one. Okay. So you can make that screen a little bit larger.
Hey, it's got this new loop function next to new wire.
Uh-huh.
Let's go straight to the loop.
You can do that. You're going to end up with a square, not a triangle.
That's fine.
Okay.
Yeah. Oh, Lord, precision. All right, just make that a little bit. Oh, I've lost it all now. OBS. Good deal. New loop. And we would be looking at this loop. I think that's the feed point.
So if it's a horizontal loop, you want to draw it in an XY. No Z, just XY. So in the bottom right hand, yeah, that's right. Click there. That's right. So now from this perspective, we are a bird flying over the loop.
All right. So
looking down upon it.
There's my length in meters.
Right.
So what do you say how many meters do we need? Because right now I'm at 80 meters.
Mm-hmm.
All right. And that would be what I have out in the backyard. Is it 80 meter loop?
Yep.
All right.
It doesn't have to be dead on. Just close.
Yeah, it's close. I'm good with this. And say okay. There's a loop.
Right. Okay. So click on OK and it'll save it.
Got it.
Okay.
Right.
Now in the upper left-hand corner where those words were, the far field plot, to the left of that is calculate and to the left of that is view. Click on view.
It's a little low to the ground. We need to raise this loop off the ground.
No. Don't worry about that yet.
Okay. Oh, because we're in simulated.
Click on view. Right. There's our loop. Okay. There are 4 wires in the loop. It's really one continuous wire, but this software thinks of it as 4 separate wires.
We need to add a feed point. Right.
That's correct. So pick one of those 4 wires. And which number wire have you picked?
Selected wire number 2. Let's find number 1 just so that we're all
okay.
Wire number 5. What the shit? I got wire 2, 3, 4, and 5. All right. Fair enough. All right. So we're on wire number 2. And I think I can just click on this actually and insert a feed point.
So what you do, once you've picked the wire that you want to work with, go up to geometry in the upper left-hand corner.
All right.
Yeah, the video is about 10 seconds behind where we are, and that's okay. So I got to stop looking at the screen.
Sorry.
That's okay.
Man. Struggling over here today.
So yeah, you can put your labels in if you want. That's okay.
We need to add a feed point. I used to know how to do this with this.
Well, that's what
See.
I was gonna show you. Yeah.
All right.
So in the bottom, so you're in geometry now.
Yeah.
So in the bottom left-hand corner,
Source.
it says source is 0. This is the feed point, the source of the RF.
We need to add a
So
source.
in the pulse box, click in there under the word pulse.
Got it. I got it. Remember, don't look at my screen.
Okay, so
I'm click happy.
Okay, so once you've clicked in there, it's in code. It's W.
Got it.
And then the wire number. I think yours is 2, so it's
2.
W2.
Wire 2.
And then if you want to feed it in the center, you put a C. If you want to feed it at the beginning, you put a B. And if you want to feed it at the end, you put an E.
Boy, how simple. W2C, enter. Bam.
Yep. Mm-hmm. And hit the enter key.
All right. Are we ready to simulate?
Nope, not yet.
No. Okay.
Okay, and that should fill in, and it did. The voltage and the phase angle, and you're hunky-dory there. Okay, now you go to calculate.
Calculate.
And you want to add some elevation, because I think this wire is pretty much on the ground the way it was drawn, and that's fine. So on the left-hand side, it says add height. And I think, yeah, you've got it defaulted to 20 meters, which is really high. So 10 meters is 30 feet.
Well, can we just not, do you want to do, well, let's do real. And so my elevation right now is really awful. But
so it's not going to be in free space. It's going to be either real or perfect. Yeah, and it makes such little difference between those two. It's almost not worth discussing. Keep it simple. That's if you want to change the ground conductivity, and it will affect it, but it's splitting hairs. What does affect it more than anything else is the height of the wire above the ground, and how long is the wire, and where you feed it. Those are the 3 main ingredients. Make it copper wire. Keep it simple.
Oh, I was actually putting the steel wire that is on the jacket of the RG6 that I'm using currently. But yeah, let's just.
Is the whole loop made out of coax?
Yeah.
Okay. And it's iron?
Well, I think it can't be aluminum. I think it's got like steel braiding, and then it's got aluminum sheathing.
I think you're overthinking it.
I am.
Yeah. It's not going to make any difference on the plot. It will, but it's half of 1%. Okay, so I would just to start things out, so that you get comfortable with the software, leave it as copper wire. Put some height on it. You get 15 meters, which is 45 feet, right?
Oh, it's gonna be much higher than that. Oh yeah,
no,
it's
you've
got
big trees then. Okay, good. You're most fortunate.
Yeah, I'm thinking my final height is going to be about 70 feet on all corners.
Wow.
By the time I'm done with it.
Wow, yeah. Huge.
Yeah, I got the big air cannon that you can change out the bead seeder.
I've got all of that, but I don't have the trees.
Yeah, I got
my trees. My tallest tree here is 25 feet. I'm right by the ocean, so I've got no altitude, no height. Anyway, okay, so you've got a frequency. You're at the bottom end of 75 or 80 meters. That's fine. Go ahead and hit on the left-hand side. There's a button there on the bottom left.
Start.
I can't see what it's. Yeah, start, and it'll run its thing.
I click it, and I don't see 0 length wire number 1. So we need to go back to this geometry. We need to basically get rid of. I think we need to delete 5 and bring it to 1. Maybe I can just delete a wire. Yeah, I can just delete a wire. There we go. Try that now. Did I fix it? No. Wavelength, 84 meters. Okay. 0 length wire number 1.
Redraw it.
Wait a minute.
It's easier.
I lost the number.
Yeah, it's easier to redraw it than to.
let's go back to drawing, which is here. No, here. Right there. Here. There we go. Can I just single line you? No. Oh, almost. Anyway.
Mm-hmm.
Well.
Yep, that's right.
Kind of messed it up. It's not really connected.
But see what it's doing? It's adding wire number 5. So my suggestion is to delete all of the wires. Start over. Just delete them and draw another square.
I can re-loop it. Not a problem.
I know, but the order of the numbers, even if you get it connected properly and you rename the wire, the software is going to be confused.
I feel you.
No,
I was agreeing with you. I was like, I could. Let's see. All right, draw a loop.
Just dump it and start over.
And this is a little bit bigger, a little bit bigger, a little bit bigger. All right, 80 meters. Good enough. Bam. We're real 15 feet. Geometry. See, we got this wire number 1 is always going to 0 for some reason.
Look at the view and make sure that they're labeled 1, 2, 3, and 4.
Wire 2. Wire 3. Wire 4. And wire 5.
You got a wire 5 there?
Yeah, that's what was happening the first time around.
Yeah, so it's the way you're moving the mouse when you're doing the drawing of the square.
Probably.
Just keep it simple. Just do a simple square. Don't worry about the size of it yet.
Okay, I can do that. Wire isn't selected. Wire edit. Okay, so I've deleted them all. I need to delete them all here.
Mm-hmm.
Yeah. Yeah.
Hit OK now that they're deleted and look at view and make sure that view is empty, that there's nothing there.
Let's go new.
Yeah. Yep.
All right. Let's make. You said don't even worry about what it says.
So what I'm seeing is you're trying to edit them, and
no. I wasn't editing. I was looking at right here. Oh, wait a minute. Let's see. XY. It's not. All right. So there's a loop. All right.
Yeah.
And it thinks it's 50 meters.
That's fine. Don't worry about it. You're overthinking it. Just draw a square and hit OK.
All right. So I got 4 this time.
Right. Right.
Let's calculate real.
You got to hit OK
15.
to save it.
Yeah. And then I need to add a feed point real fast. Let's add. Mover adds source to the center of the wire right there. So now we have a feed point, wire 4 center. And now we can simulate this. And we've got a frequency, which is not what we want for this loop. But here it is. And here's our far field. And then we can go 3D far field. Add a 5 degrees, fine. Cloud burner. What was that? SWR of 177. But that's okay.
Right.
I wonder what was the impedance.
So, yeah.
Okay.
So it's a high impedance, very high impedance.
Yeah, 1700s. Yeah.
And look at the J.
35. No, 3500.
Is it a positive 35 or a negative 35?
Well, there's a dash in front of it.
Then it's a negative.
Could be a negative, right?
So I'm going to quiz you. Does that mean that it's inductive or capacitive?
Capacitive.
Right. Exactly right. So that tells us the antenna is too short for that frequency. Inductor, it's too long. Capacitor, it's too short.
Capacitor is too short. We have a button here for this.
Well, I was going to suggest instead of redrawing or changing the size of the loop, just change the frequency.
You want to take a gamble on this optimization?
No, just change the
All right.
frequency. So
Let's
you're
go-
looking at 3.5 roughly.
Yeah.
Okay, go to the next band up. Go to 40 meters, and run the software and see what it does.
Ooh, 8.31 on the swears.
Okay.
But
So
we get this bubblicious. Oh man.
But what's important is look at the pattern is important, but also the match. Look at the impedance, the resistance of the antenna, and the J factor. The J factor tells you pretty much everything you want to know. If it's a positive J, it's too long.
Positive J at 146 ohms.
If it's positive J, it's inductive. It's too long.
Right.
If it's a negative J, it's capacitive, and it's too short. And this only applies if you're feeding coax. If you're feeding balanced line, that number doesn't really matter.
Wait, this is a fun 40-meter pattern here. You could have like local, the guys across that way and the guys across the pond, all in one antenna.
Yep.
This was so great.
And you'll notice as you go up in frequency, go to the next band, go 20 meters and run it again. And what you'll see is there are more lobes. Every time you go a multiple up, there are more and more and more lobes.
Wow, did it have to work for that one? Did you see that?
Mm-hmm. Yep.
Oh, wow.
Yep, the higher frequency, because it's computing all the extra lobes. It gets exponentially more complicated for the software. So there's more of a delay.
Oof.
Mm-hmm.
Boy, look at all that power being strung thin.
But it's all low to the horizon.
It's very low, isn't it?
Mm-hmm.
It's very little loss going straight up.
Mm-hmm.
Oh, I love it. So it's actually a DX machine on the higher bands.
Yes.
Ah.
Exactly. And that's why a lot of people, if they have the property, they will put up a big horizontal full wave loop. They'll feed it with balanced line because then it becomes a multiple band antenna. You'll only use the one antenna, and that's that. You don't have any interaction between two antennas, two radios, one you're transmitting, you got to unplug the other one, you'll blow up the front end and blah, blah, blah. It just keep it simple. And it just works. It works great.
You just have your big ass loop and that's all you need. Yep. I have really been blown out of the water on how quiet. I mean,
they're exceedingly quiet. Yes.
Has almost brought tears to my eyes to listen to this, because the only time I've ever heard a noise floor this low is when my entire county had lost power and I plugged in my Bio-Inno into my radio, and it was early in the morning and I was like, shit, I'll get on the radio, see what's going on. I was like, whoa.
Yeah.
This sounds like a phone call.
Yeah, exactly.
Better than a phone call. There's no like intermittent dropouts.
Yeah.
So we were getting close on 14. Let's see. So we were long. So let's go 13 megahertz.
Sure.
Yeah. And again, we're going to have a longer processing.
Yeah, there you go. Yeah. You got it.
We're going to have a longer processing time.
Mm-hmm.
Because we, again, went down. All right. So no real difference going on there. Oh, boy. Come on. Catch up. And so we have, all right, so now we've gone from a lower to a higher ohmage. Now we're at to a positive J of 780 ohms.
Mm-hmm.
So we've gone too far.
Yep. Right.
That is a funny side radiation.
You're approaching a half wave. When the Z, the first impedance, the first number goes sky high, and the J flips. It goes sky high and it flips from inductive to capacitive. That's when it's exactly a half wave, a multiple of a half wavelength long. Which can be a good thing and it can be a bad thing. It all depends on what you're feeding it with. If you're feeding it with coax, coax is low impedance. You don't want to be feeding a half wave. You've got a huge, 75 ohm or 50 ohm to 3,000 ohms. You're not going to get any power into the antenna.
Getting closer.
Mm-hmm. Mm-hmm.
Let's see.
This is much better doing it this way, what you're doing right now, changing the frequency, because you'll immediately start to see how one interacts with the other. How does it change the pattern? What does it look like? What does the impedance do? And this is why I try to get everybody to stop looking at SWR, because SWR only shows you one very, very small part of the whole. Everybody, we're always fighting for the holy grail. Oh, it's 1.5 to 1. That's no good. I need 1.11110 to 1.
No,
No, you don't. No, you don't. No, you don't. Come on.
It's part of growing up in your ham radio hobby is realizing that a 2 to 1 is still usable.
Absolutely.
Yeah.
Absolutely. I can tell you now, I'm different than what you're doing. I'm using balanced line. I'm using homemade 600 ohm line.
That's so gangster.
But here's the deal. On my feed line, I can have a 30 to 1 match on the line, and I still get about 80 to 90% efficiency.
Oh yeah. Yeah, because most of it's on there.
It's like hard line. It's amazing. Coax is good stuff. I'm not throwing it under the bus, but it needs to be matched at both ends. Absolutely. And if you use balanced line, that match equation, it's not really important anymore.
I have a feeling I'm going to regret. I'm going to save this as regret. REGERTS. Regrets. Optimization. What are we optimizing? All elements. Start. Are you working?
I have used this software so many times. If I had paid, $1,000 for it, it would have paid for itself already. It is just superb. Real easy to use. It's a good teaching tool. I wake up at 3 o'clock in the morning and go, what happens if I do this? And boom, you go at it. The next thing you know, it's 7 o'clock and the sun is up and you go, oh no.
I can't wait to get lost in liquid. It's done to me.
Uh-huh.
Yeah. I picked 10 meters, Hollywood.
Yeah.
Oh no. It's not 10 p.m. where it is where you are, is it?
It is.
Oh, okay.
Yep.
DeSantis time.
Right.
Oh, what have I done? What a waste of time. Let's go back to some lower frequencies. And yep, had enough of that. The calculation was interrupted. Frequency. Let's go back to the fun frequencies. Or the fundamental. Let's go back to the fundamental. And let's optimize it.
And now that I'm looking at the StreamYard video, there's no delay. Suddenly, there's no delay.
Oh, you're looking at the damn YouTube.
Yeah. Stop doing that.
Oh, Lordy.
Stop it.
All right, there we go. Here's some optimization. All right, all right. I was about to say that's a little bit more than what I'm used to.
Yeah.
It is really plugging away at this thing.
Yeah, and it, depending on how many parameters you have it try to zone in on, it can take a while. And this
Well,
is
it
just
got
a simple loop. If you did like a 7-element Yagi, it starts moving the length and the spacing between them, and then it's not a mono band. It's 5 bands, and it can take a half an hour.
so. Let's see here. So we've got our swears down to about 4,
Hmm.
which I'm impressed with. So that
Hmm.
immediately makes me want to go. What does this look like? Why don't I have a 3D option? Oh,
Uh-huh.
I
Oh,
didn't start.
now
I
this is
didn't
that.
start it. I optimized it, but I didn't run it.
Yeah, but you know what?
What?
What you've got right there is such an important tool.
What's
Let
that?
me explain.
Let me go
Because
back.
leave it right where it is. Because
Okay.
what you've done is you've got a great match, but you've got an inefficient antenna.
And
This
boy,
is
is it
why I
a
tell
banger
everybody.
on 80,
Everybody's saying I've got a 1-to-1 match. I said, so is my dummy load.
right?
You know,
But my
don't
dummy load's got a better match than your dummy than your antenna.
Right, right. So if we built this antenna, great, we got a good match. But so what? It doesn't talk. It goes straight up. You're better off with the one you had before that goes low to the horizon. We can chase the match with a tuner. But if you build the antenna specifically, your number one criteria is that that wire has to have a really good SWR, then it's a high probability that the pattern will be terrible. And the whole goal of building the antenna is so that you can get the signal from point A to point B. Doesn't matter what the match is. Don't worry about the match. That's later.
We've got some friends in the chat.
Oh, good. See, I can't see them
Yeah.
because I'm looking at the StreamYard.
So we've got Chris Robinson. The Smoking Ape is here.
Hey,
Mike into MAK, and Prep and Paul's been hanging out with us for a while. Yeah, we got some of the guys with us. That's pretty great.
excellent.
So this is pretty much our 75-meter Orlando banger right here. But if we want to,
But that's after it's been optimized, and I bet you that antenna now is really short.
let's look at its geometry. So we've basically got.
You can go to view, go to the view tab, and just
Okay.
just snap on one of the lines. Yeah, see, it's a rectangle now.
It's a rectangle. You know what? It was chasing that 50 ohm.
Yep.
That 50 ohm rectangle, that 2-to-1.
Right.
That's what it was doing. I believe I'm upside down even. Yeah. I'll be darned. It was chasing that. Anyway, that's kind of a weird frequency to be on. More like 375. Optimize.
So what was I missed it, but what was the length of one of the 4 wires?
Let's go back to the geometry. So we've got 21 meters. Seems to be the consensus.
No, that's the
Y1.
That's not the length.
20,
that's where it starts. So click on view.
Yeah.
And in the bottom right-hand corner, look at the length.
40 meters for this leg. And then this leg is, get it, 21 meters.
Okay, so that's 60, those two. And then you got another 2 that are going to be the same. So it's 120 meters all the way around.
I think. I mean, wouldn't it tell me?
It does, but it doesn't. That chart doesn't show you under geometry. That chart does not show you the length. It shows you
the points,
the starting and the end point.
Well, then
in a
why?
3-dimension. So that's why I say it's great if you're used to doing CAD CAM and this is second nature to you. By all means, go ahead and look at the geometry chart and you'll fill in the numbers. But if you're starting out, I would highly advise not doing that. Just look at the view, snap on a line, and you can see where it's going, and immediately it shows you how long it is.
Hey, check this out. So
Yeah.
in Wire Edit, if you
Yeah.
select a wire and click on it, and then you go
Mhm.
to wire definition, it'll tell you the length of it right here.
It also does in the up. You don't even have to do that. In the upper right-hand corner, it shows you the
76.
length next to the
Yeah, there it
bottom.
is. I see
Yep.
it. Length
Yep.
76 meters,
Yep.
76.7 meters. Okay, so
Right.
and then that's going to be the same. And that's a 50-meter length, and that's a 50-meter length. Boy, talk about some AI fingers of trying to bring a loop to 50 ohms. It really tried and failed on that one.
Yep.
Anyway, that's still fine though, because you can't really mess up the orientation of these things too bad.
Right.
Um,
It's very forgiving as long as you keep referring back to the view tab and you look at it and you go, oh, it's 3 states huge, you know. I've got to buy Arizona just to put the wire up.
let's play with 10 meters.
Mm-hmm.
And we've got a negative.
You're on 30 meters.
Oh, I'm sorry, 10 megahertz, 30 meters.
Yep.
Source is not important, but we are capacitive because we are negative J, 600 ohms.
Right.
So
you have a very high impedance there. Really bad match for coax. You would have to put the tuner between the coax and the antenna. You cannot put the tuner in your shack with those numbers.
No.
You'd be pushing 100 watts in the shack, and you'll probably get about 2 watts at the other end.
So the rest of it would just be dancing with you.
Yep. It's all going up in heat. And this is where a lot of people get into trouble, because then they say, well, I just need an amplifier. And now they go from 100 watts and they're pushing, 600-700 watts. And then the balun cooks and the wire arcs over, the PL259, there's a little bit of water ingress or whatever, and poof, up it goes.
So here I've run it again. I've gotten off of 30 meters. What did I run here? I think it was 14 meters, or I'm sorry, 14 megahertz. Yeah, again.
Yeah.
Again, back to here. I wanted to run something, just one more. Let's go 15 meters. I don't think. Oh, my word. My computer is showing.
Well, look at all those tabs you got open on the bottom.
Oh, please. Don't even start. I'm not even halfway used up here. I still got another couple gigabytes of memory, just not doing nothing. But, I do have a couple Chrome tabs open, so.
Mm-hmm.
No fatal errors this time. So we are, it looks like, a positive. So we are inductive. So we are long.
Mm-hmm.
We got a swerve of 24. Doesn't matter. Let's far field this thing. Oh, boy.
So immediately off the top, I see on the left, it's a lot more symmetrical.
It is. You're right.
I see on the right-hand side, I've got 2 big lobes going out to the horizon. I've got some stuff going upstairs, and that might be okay for, shooting the DX.
Yeah, that's not a bad one.
It's not terrible. It's not terrible. It could be better, but it's not terrible.
Nice low lobes there.
Yeah.
Let's see how they look in 3D view.
Yeah, the 3D view is really.
Oh, it's
really
directional, kind of.
Uh-huh. Yep.
It's directional. Now, let's figure out which way it's directional. Looks like we have a X positive and a X negative.
Right, right. And it's shooting at the X minus. So look at your view and see where the feed point is.
Is that
little dot, that circle?
Right
That's
here.
the feed, right?
And there's
Is
X.
So the X minus is on the opposite side. Yeah, right. And that's where the RF is going.
That's where the gain is on 15 meters is away from the feed point.
So, and in front of it, it's shooting forward. That's where the RF is going.
Yeah, our feed point's back here.
Mm-hmm.
Cool. So on 15 meters, an 80 loop is very directional. Boom.
Ordinarily, it would not be there, but the way that we've drawn this,
sure,
it is.
This dinner table, right?
Yeah.
Ape says we just need a second feed point to balance it out.
Right. Well, that's been done. What you can do is on the opposite side, you put a knife switch. So
Ape and I, we were just looking up knife switches the other day.
Yep. Knife switch and a piece of rope, and it's spring loaded. So when you open the switch, it's a dipole. It's a bent dipole, but it's still a dipole. And that 80-meter loop will now be a dipole at 160. When you open it, when it's not a closed loop, when it's open, it works on the 1/2 of the fundamental that it's cut for.
Right.
And if you take a dipole and you join the ends together and you make it into a loop, if it's an 80-meter dipole and you join the ends, you then have a 40-meter loop.
I found it. It was under HF simple loop. Look at all these loops we have to choose from.
Magnificent.
Oh, loop. Lots of 20 loops. My word.
Here we go, loop-de-loop.
Yeah, let's pull up their 80 asymmetrical loop. Oh, this is interesting.
Put your seatbelt on.
It even goes in different.
Oh boy.
Oh no, what? I can't. No, sorry. That's even too wild for the 70.
Everybody just took a sip of something.
Yeah, that is even too wild for the 75 ohm ham. It's only 10 o'clock. All right, that's what I'm talking about. Here's our 2-to-1, our window frame.
Yeah.
All right, and then we fed it somewhere. Let's calculate this thing for 20 meters in real, and we are 15 meters above the ground. Let's run it. All right, so what did we run? We ran at 20 meters, and this is a 20-meter loop. So this looks correct. We should be going on our fundamental up and away. Let's see what we're doing here. Beautiful. Oh,
magnificent.
Oh man. So this is the loop is a hanging loop. Right.
Yep.
Where's our feed point? Right at, where is it? I can't tell. I've got to go back to see where the hell we're feeding this thing. We are feeding it off to one side. Oh, look, we get current distribution. Wonderful. Current and voltage.
I think I just had a flashback to Lidsville. Do you remember Lidsville?
Don't be a lid.
on Saturday morning with Charles Nelson Riley.
Oh no. Where is? All right, so we've got to be feeding it on one of these short sides.
Yep.
And right in the middle. But this is the classic, because you can see it right here, the classic 2-to-1 split on the loop. So really, if you're cheeky, you kind of only need 2 points to make this loop. Just hang it here, and square it off at the base. Feed it in the middle. That's your next tricky part. But my God.
And if you have really good soil conductivity, you can lose the bottom wire. And that's a half square.
Oh, we could just half square it.
Uh-huh.
Yeah, you're right. Now, does the wire length need to maintain, obviously, for resonance?
Yes.
Okay, but we still need to maintain this 2-to-1 aspect ratio, just minus the bottom leg. Got it.
Right.
I want to see, because we are into the purple, but what is this? It's kind of high for the, so where are we in this purple? Where are we at? 41 degrees. That's pretty damn high.
Mm-hmm.
Where was this one at, though? 11 degrees. Not terrible. Where are we on the null? Almost 2 dB at 20 degrees.
But you know what? It will still make contacts.
Yeah, damn right it will.
And actually, I think the drawing on the right is accurate, yes, but I think you're looking at it sideways. Yeah, you use this model. Use this model. And in the bottom left-hand corner of the screen, there is there's a button that you can click on. Yeah, there you go. Okay, now you take click on azimuth.
Okay.
The box.
Bloop. Yep.
Yep. And now you can move the two faders there on the left-hand side. The so you can spin it around, left, right, up, down.
Oh, it's selecting a slice and then a.
Yep.
Oh, it's a full direction. Okay.
So you clicked on something else because you lost the fill-in colors. You've got a wire. Right. There you go. Yeah. So if you take that cross-section wire, that purple wire that's there is a function of those two sliders. And there you go. So now where those two line up is in the hot spot. And now read your gain, 4.6 dBi.
Okay. So, wow. 4.5 at a maximum.
Yep. If you move it around, if you take that line and you put it on the green in line with the wire antenna, you'll see your gain. So you got a negative 4, negative whatever. Yeah. Mm-hmm. Yep. That's the null.
That's a pretty good trade-off there. A negative almost 5 dB on a null.
Well, it's the difference. It's the difference between the null and the forward gain. So it's a -4 all the way to what was it when it was peaked out?
4.5. Right here and here.
So that's a +4. That's an 8 dB difference.
That's a lot of dBs.
So 10 dB is a factor of 10 in wattage. If you have a 100-watt radio and you have a 1,000-watt amplifier, you kick the amplifier on, that's 10 dB. So 8 dB is, it's not quite there, but
it's not worth glazing over either.
It's significant. Yeah. Yeah.
Look at this. I wanted to point out the null right up top here.
Every 3 dB, you double your power.
Can I? All right, so I can get that. Can I? Oh, yeah, I can come into. Right? Yeah, it doesn't matter where I am inside of here. It is 20 dB def right at the. Right at the.
That's the big null. Right. So if you're a plane flying overhead, you do hear nothing. And that's also what happens on a vertical. If you have a quarter wave vertical and you fly directly overhead, it's like 100 dB down. It's nothing. You don't hear it. You hear the noise floor of the transistors in the radio are stronger than the signal that you pick up if you fly directly over the top of the vertical tower.
GP40 geometry. Run it. View it. All right, so here's a vertical. Here's that null. Get my far field of a vertical. Here's your vertical. Beautiful.
Well, the vertical is too long because it's shooting signal straight up.
It really is, isn't it?
Yeah, it's too long for that frequency. How if you go to view, what's the length of the wire?
Oh man, it says my swears is 2.3. If I go to geometry, well, hold on, I have to go to view. Here's our view. Okay, so we are a base loaded quarter wave.
Oh, okay. Well, that's why it's base loaded. Okay, yeah.
And this is.
What's the length of it?
I need to go here. Maybe?
No, you don't. You can, but you don't need to.
There we go. So I can.
It's 10 meters.
There it is, 10 meters. All right.
Yeah, it's 30 feet tall. And what frequency are we feeding it?
Not 7 megahertz.
Which is 40 meters. 40 divided by 4 is 10. It's a quarter wave vertical. Right?
So is it a 10 megahertz vertical? Is that what you were?
No.
Quarter wave.
7 megahertz, which is what you had. That's the 40 meter band.
Right.
40 meters divided by 4 to get a quarter wave, 1/4. A quarter wave divided by 4 comes up with 10 meters. That's the height of the radiator.
My brain was somewhere else. I'm sorry.
Yep. And I went fast. I went through it. Yep.
Thank you. 3D far field. Did I not? Okay, so
but there's something really funky going on with the far field plot. That's not what I would expect to see. I would expect that to see a much lower radiation pattern, not up in the sky like that.
So
if you go ahead.
It seems on the view that we have radials, right?
Mm-hmm. I would draw it. I would draw it from scratch. I wouldn't do one of the saved ones.
I mean, it looks pretty good, but also this is named a GP40, so it's got a ground plane, and it's for 40 meters. I mean, it's as basic as it gets. Let's go to see geometry. What's going on here? There's only one feed point, wire 1 at the base.
Mm-hmm.
Yeah, I couldn't draw it any better, I don't think. That's a perfect quarter wave ground plane. But also too, it's only got 4 radials.
That's all you need.
Yeah, that's true.
Hey, stand by for news. I'll be right back.
Yeah. You know, I'm going to get a beer too. Thank you guys for hanging out with me, by the way. I really do appreciate it. There's all 10 of my good friends here. And if any of you want to jump in, just scroll all the way to the top of the comments and all the way to the top. Yep, there's a link right there. I'm going to go grab a beer. Hollywood. Let's see. I want to put that up. I'll be right back, guys.
Did I make it back in time? Or are we still on? Is the record still playing?
We can flip it over one more time for you.
Yeah, right.
Right.
For those of you at home, if you hear Michael Martin Murphy, Wildfire, trust me, the guy's using the bathroom. Because it's a long song.
It's a very long song.
Yeah.
Inverted L. I love an inverted L. It's almost the closest thing to like a square.
Yeah, it's adding top loading.
Oh my, look at this. We have a swir of 1.03.
And top loading is always, it's almost lossless.
Top loading.
Yep. Capacitive top loading. This is 1/2 of a capacitor. If you were to draw in another horizontal, so it looked like a T instead of an L. So what that would do is it would draw up the electrons from the bottom of the vertical all the way to the top. And of course, it's a closed circuit. They have to cycle back to the source, back to the ground. And that's the other plate of the capacitor is the earth.
Okay.
So it goes up through the inductor. That's the wire, the vertical part. And
that's
then it goes
the red we're looking at.
Yep. That's the current. Yep. Right. Well, actually, they're both current in this software. It's showing you both currents. It's red because it's vertical and it's blue because it's horizontal.
Oh, okay.
Those lines are showing you where the current is.
Right. Yeah, those are always.
And you'll notice at the end of the horizontal, it tapers off. So there's no current, right? There's no current there. But what about the voltage?
Highest point of voltage.
You got it. Yep.
All right, so I guess obviously we are on the fundamental of this thing because this is bubblicious.
Yep.
What was our fundamental? All right, so this is an 80 inverted L.
Yep.
Yeah. It seems to be a real shit 80 antenna.
No, not at all.
No,
no,
so?
Not at all. Not at all. That thing will work beautifully.
Yeah. That's a hard angle for 80, is it not?
No, because you cannot get the wire. I mean, it's very rare that you're going to have a 200-foot tower. Like,
oh, I see what you're saying.
Tim Duffy probably can do it, but most of us, we don't have the funds. So, up and over for an inverted L and just go with it. What's more important is the ground radial field, the ground conductivity. If you're lucky to live near salt water, then the inverted L will go gangbusters. I can do like 1/10 of a watt on 160, and I can see it 3 states over.
Well, that's because most of your antennas
under your feet. That's right. That's the other half of the antenna that nobody wants to talk about.
Nobody wants to talk about that. No. It's like dementia. They don't want to teach children that in elementary school because it's just not a fun topic. But when Grandpa, in my experience, when Grandpa starts hiding the damn silverware, and we ain't got nothing to eat with during breakfast time, yeah, time to have this talk. Let's see.
But that's another thing I love about this software is it shows you where is the current on the wire. What can I expect to see? That's really important.
So here we are here's our inverted L. I have to view it. So where is X and Y? So X is off to the right, Y is facing us, and here's our L. Okay.
Oh, you just froze up for a minute there, and I got the hourglass.
Oh boy, let's see.
But you're back.
This is on 10 meters. This inverted L, this 80 meter, right? Yeah, this 80 meter inverted L on 10
Right.
meters.
Right.
I can't. It's interesting how quickly it calculated an end fed wire, if you will, versus that loop. That loop was a hell of a lot
Right.
more processing power going off
Right.
there.
Exactly. Yeah.
So we are slightly, but ever so slightly capacitive, but that's okay. But this thing looks so crazy.
Right. So let's talk about that for a minute, because that's also really good. That's an important lesson. So why do you think it's putting so much signal up into the sky and less toward the ground?
Because half of it's beaten up and half of it's beaten down, I guess, because of the horizontal. So you're gonna have this this way.
Do you know the name Harold Beveridge?
That
The
beverage
beverage
word.
antenna?
That beverage word rings a bell, doesn't it?
So a beverage antenna, yeah. See if there's one in there. There probably is. A beverage antenna is a really, really, really long piece of wire. Like, a lot of guys will say, "Well, I'm running a long wire." No, 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 you're not. No, you're not. A beverage is like, 5, 6, 7,
So
10
long.
times the wavelength.
So
It's
long.
thousands of feet long.
Thousands for sure.
Okay.
Yeah. Like an actual beverage like people
Yeah.
want to talk about their long wire and then they want to, I've got a beverage and
Right.
I'm like, yeah, how big's your resistor at the end of your beverage?
Right. Right.
Resistor.
So a
What are you
beverage
talking?
antenna is a highly directional antenna.
And
Because of
just
its
like
length, all of those lobes, they start to change their phase angle and they combine. And at the end of it, they're all shooting in the same direction. And that's what was happening with your inverted L when you went up to 10 meters. It's so long for that frequency. It's
right.
so big that it ends up shooting off straight up and out off the horizontal part.
Whoa.
And not hugging the ground.
All right. It's not as dramatic as I thought.
Yeah. You got a Yagi there, right?
It's a beverage.
Oh, that's a beverage. Okay. Oh, rock and
So
roll.
here's the view. It's
Yep.
basically a wire on the ground.
Right.
Then we're going to look at we're going to look at the wire with wire edit. And we're gonna click it. It's 350 damn meters long. That's a lot of meters.
Mm-hmm.
My word.
That's 1,000 feet.
My word. But all right, let's do the 3D stuff. Let's see this thing. Do it. My dog is wanting to go out. My God.
Mm-hmm.
That is so awesome.
Now, what happens if you put two beverages and they're maybe 30 degrees? They point, the points are close together, but the ends where you're feeding them are way out. And the angle is 30, 45 degrees, somewhere in that ballpark. Hmm.
Come here, Daisy. Come here. Daisy here is giving me the sign that she's got to run out.
You're getting the eye. Yeah.
Give me 20 seconds.
Yeah. Yeah. And I'm going to go and see on the regular YouTube stream. Check the chat here because I don't see it on the StreamYard. So yeah, so Paul is still here. He's laughing, and let's see who else.
She didn't want to go out when I opened the door.
See, she just wanted Daddy's attention. That's all.
Oh, she was making that sound like she was about to poop in the house.
Uh-oh.
Yeah. Just got my heart racing there. I was like, oh, hold on.
Chris says Bell had multiple antennas and loops. Yes, absolutely. I talked to today. I worked the Bethany. I worked the VOA station, and yeah, they had loops and yagis and beverages and all kinds of good stuff back in the day. We had one here on the Cape. Was WCC, and I was most fortunate before it was taken down. I got a tour. It's uncanny. I just happened to be in the right spot at the right time. Ended up just driving by on the bike and on the motorcycle, and it was a Sunday afternoon in the fall, and I knocked on the door and said, "I'm a ham," and the guy answering the door said, "Come on in. I'll give you the red carpet treatment." And oh man, it's just fantastic stuff. This is in Chatham on the Cape. And that station, for those that don't know, WCC fed one half of the globe, Morse code, telemetry, shortwave, to the ships at sea. And the other big station was KPH, and that was in California. It's still there. And it's a museum now. So KPH and WCC, those are the two in the US. And now back to our show.
And now back to our show. I found a antenna dependent on tuner folder. A Delta 80-40. What does this thing look like? Oh, perfect. Hey, look at that. That looks familiar. All right.
Yeah, Chris, KPH. Yeah, I'm reading the chat. Used to work at almost every 10 minutes. Yeah, great stuff.
Oh man,
great stuff. They have an SDR. You probably are aware of it, Chris. But I have it on my in my bookmarks to use the KPH SDR when I want to listen to something out in the West Coast. Great stuff.
So here's that 15 meters again on the 80-meter loop. And again, we got a delta. Now, the thing about his delta is that we have two lowers, but we're feeding it at a top corner, is what it appears. If I got my X, Y's, and Z's in the right orientation. But I can double check that if I just look at it in 3D.
Is that the Helen Reddy Delta Dawn?
Oh, boy.
I'm sorry, I can't help it.
Yeah, well.
I see the damn records going around in my sleep, you know?
So before, when we were modeling 15 meters on a square, we had a very directional, but now that we have a triangular loop, now all of a sudden our very directional has become this almost symmetrical kind of orientation.
Right.
See where, and we are corner fed. Was this corner or center? I forget.
You have to go back to the view tab.
This was top corner
Look at
fed.
that little red dot. Yeah.
Yeah, top corner fed is what this is. So this isn't a bad loop. I mean, this is actually a really simple loop that you could do because all you'd have to do is just have one high point.
Right.
Oh man. So with that being said, I believe that we're calculating them. No, we're real ground set, but we're also 20 meters.
As long as you use a choke. I mean, you got to make Ape happy. Always be choking.
Yeah, well, choke at the antenna and then do it again for, because the good Lord's looking at you, whatever you're doing on the inside of the shack.
Yep.
I actually made Ape a whole bunch of chokes. Did you hear about that?
No.
Yeah, I made.
I saw the last one that you wound, which was great. I didn't know you were making a bunch more.
We decided that we needed to have a lot of them.
Good. Good.
So he sent me a box of 20 to my house.
Oh,
and
great. Yeah.
I figured out a very fast and effective method. And on top of that, I actually this one's not shrink wrapped, but because they're pretty boring when they're shrink wrapped. But I measured shield to shield like we did the other day. I
Right.
put a birth sheet on every single one. I printed it
Wow.
out. I printed it out. Yeah, I'll show you. Every single one has a of course they're all very very similar, to within decimals of each other. But
Yeah.
yeah, I was like, everybody's selling chokes like this all day long, but you don't. From the audiophile in me, whenever I get an amplifier and I have a birth sheet and
Right.
somebody's signature
Right.
and like
Right.
test equipment printout shit,
Right.
that piece of paper is half the worth of the
It
product.
it is. When I was modifying the D104 microphone, and that was my business, and I would do the same thing. I would give them a certificate of authenticity with a serial number with my signature and the spectrum analysis and the whole thing. And yeah, it's amazing what people value. I didn't, but it's okay. It's all good. It's all
Yeah, I
good.
mean, it's old
If
news
it,
to
you
you,
know, if box that it came in, it's worth 100% more. You throw the box away, it's worthless.
right? Yes. So now that you've brought
Yeah.
up the box thing, I have
Yeah.
never been a box person
No, me neither.
until this year.
Uh-oh.
Okay,
Yeah, I see him. Yeah. Yeah.
so now, now,
Save your
now,
empties.
now I'm afraid to throw boxes away. Thank
Right.
you. Thanks, fellow hams, for giving me this new complex.
Yeah.
Right, because if I throw away,
I just spied the big logo you've got there next to the TV. Where
oh,
did that come from?
I'm not doing it right.
Holy. Or is it? Oh, you know what it is? It's in the video.
It's pretty
It's
slick,
in
right?
the video. Look at you go. I thought that was a sculpture the way I was looking at it.
Not bad,
I
right?
did. When the thing was open, when the door was open, it looked like a sculpture that you had there. I said,
need.
"What? Did he make it out of wood? Did he paint it black? Where did that come from?"
I would. I really.
Yeah.
See what
Yeah.
I did there?
Yeah.
It's a
Very
wood
good.
sculpture. So our delta loop here. Let's change this feed point to a little
Mhm.
bit more real. Well, it's not going to. If we just look at this thing in free space,
Mhm.
it's
It will do that because you'll see that it'll change the takeoff angle.
so here's our.
Put the
Oh,
software screen back on the on
sorry.
StreamYard. Yeah.
Bloop.
Because now what you're looking at is
What it
the
wants to do.
wire and the wire itself. Not this is like playing. This is
Oh,
like
look,
playing pool,
look,
like
look,
billiards.
look! All the gain is in the ground.
Yes. Yes. Right.
Yeah. So
Right.
here we are, level to Earth. Right. Level to Earth. I wish I could zoom in a little bit.
This is why modeling software like this is so cool, because most people that have never seen this, they don't understand. It's a wire, it just works. No, well, it does. Yeah, but where is it going? It's bouncing off of the ground. It's like playing billiards. You want to sink that ball over there, you've got to go off the bumper and then hit it. And that's what that antenna is doing.
How much are we throwing at the ground right here? Oh my God.
It's a worm warmer.
It is. It's like 5, maybe 6 dB
Mhm.
of gain. You're just throwing straight at the ground. 7 to 7
Mhm.
dB.
Mhm.
Oh yeah, it's working great.
No, it was. It was. If you model it on the ground, it does. It's a good antenna.
Right. You're right. I am in free
Yeah.
space. Let's do real. Do it. And totally different beast.
Right.
It
Right.
wants to get away from the ground so bad. So bad. It doesn't even want anything to do with it.
It's ricocheting off of the ground.
Assuming you have a ground. I don't know. I don't
Well,
understand.
got a ground. Everybody's got a ground. It's just a question of how good a ground.
I have.
But even if you're in the Sahara Desert, I mean, this thing won't hug the horizon, but it will do something. It won't be like it's in free space, even though it's sitting on sand.
So, in your experience with ground, like real Earth ground,
Mm-hmm.
what has what what is notable as far as like field deployment antennas and the type of ground that you can describe so that we all kind of have an idea? There's Sahara Desert ground, and then there's Florida swamp ground, and then there's
Well,
like your example, you have some salty water ground.
the two extremes are just that. The Sahara Desert is on one end of the spectrum, and on a boat in the middle of the ocean, salt water. That's the other end of the spectrum, and everything in between. The more conductive, the more like the ocean, the on a vertical, the better the antenna is going to put out. And if it's a horizontal, and this is a 45, but the more it's going to bounce. It's also going to bounce even after it leaves your antenna. It goes up to the ionosphere, 1,000 miles away, comes back down, hits the ocean, bounces once, twice, 3 times, ends up in Europe.
So we're looking at 50 megahertz right now on this delta loop that has a high apex.
I'm on the East Coast, Ziggy, so I can talk 100 watts every afternoon in England without breaking. And if I try to shoot to California, forget about it.
Not happening.
Over land, not over the ocean. It's very efficient for absorption.
I gotcha. Boy, I can see what you were talking about, losing track of time with this stuff.
Yep.
I could sit here, man. This is better than drugs. I can just make
Jane's
my own
addiction.
visuals. Yeah. You want to see colors, boy? You want to hear them sounds a little better? Boy, look how null it is off to the side. My God.
Or TV as a kid, so I stuck a magnet on the front.
Oh, yeah.
Dad was not happy.
Oh, well. You'll appreciate this. So in St. Augustine, there was the original Radio Shack, which was a family-owned franchise Radio Shack. I'm sure you've seen those.
Tell me again, because you
bopped.
You locked up for a minute there. Yeah, go ahead.
It's so it's a Radio Shack, right? Like probably in the 80s, 90s. Mm-hmm. They recently closed. I think it was just into the 2000s. I remember it was around the Obama era, but anyway.
Right.
It was a family-owned Radio Shack, but it was a pure franchise. Like they sold like washers and dryers and
wow.
The microwaves, and they did like actual boob tube TV repair, still doing VCR repair, and they had like anywhere from 2 to 6 technicians a day in the back. And you could talk to the techs. Like each one had their desk, and there was like an open walkway and then wall and then open walkway.
Not like at the truck stop.
So you could all any tech had to do was just walk either this way or that way from around his desk, and you could have a conversation with the tech.
Yeah.
And I did the speaker magnet on my my family TV. So I rode my bicycle up to Burton's Electronics.
Mm-hmm.
And I said, "Please, mister, let me borrow your demagnetizer."
I'm in trouble.
And he looked at me and he said, "I don't lend this out."
Uh-huh.
And I said, "Well, that's it for me then." And
Goodbye, crew world. I'm off
yeah,
to
right.
join the circus.
This thing's great, right? Because he looked at me up and down, and he went and he got it, and it is pure magnet wire with
Right.
electrical tape
Right.
holding its form, and a damn grandmama's lamp cord attached to it.
That's right. The old suicide cord. Mhm.
I don't know how, like, I don't know how it didn't throw a breaker. It's because it's a big inductor.
Yeah,
If
that's
it was
right.
just, if it was just
That's right.
right, it's fighting itself every time it goes
That's
around. It's like,
exactly correct.
"Ugh,
Exactly correct. At
get out of the
DC, it's a
way.
dead short, but at 60 hertz, it has inductance to it, and it
Every
restricts.
every single wave pass, it's like, oh, you're getting in the way again.
Yep. Yep. That's a good way to explain it. Yeah.
Presenting some resistance back here. I'm going slower. I have to fight another wave around this coil.
Yeah.
So, but
Cool.
yeah, it always blew my mind because I was a child of DC only, and then I was thrown into the world of adulthood when I became an electrician's apprentice. And then I had to slam everything that I knew and accept reality as it wasn't, because AC is, from a child's point of view,
right.
It's voodoo.
Yep.
It's absolutely brutal to think about. And especially, I wasn't taught it, I was thrown into it. So there's that.
Yeah.
But the electrician school I was in, they paid for me to go to electrician school, which I thoroughly enjoyed. Yeah. Oh man. And I did so well because I told all the other guys, I was, I'd even stay after class because I was like, guys, it's so simple. You're either going to multiply or divide these two numbers that they're giving you already. Just go ahead and do both. And whichever one looks the best, just pick that.
Right. Yeah. Yeah. Yeah.
Oh, well.
Yeah. It's cool stuff. It's cool stuff. And it's all related. And if you, because when I was teaching, I was, you start with DC and then you go to AC, but I would always add in, once you get the AC part of it, don't get hung up on the math. I hated teaching the math part of it. I just want to teach the concept. And then, understand that it's one day it's alternating current going down a speaker wire, pushing the cone of the speaker back and forth. Audio. That's alternating current. Oh, but it's alternating current coming out of the wall socket. Oh, but it's alternating current going down the coax to the antenna. It's all the same. It's just a different frequency, and it behaves a little bit differently. But once you grasp one, then you can build on the others.
I just randomly picked this.
Mm-hmm.
And my God. How do we have
What have you done?
how do we have such DX and such invis at the same time?
Uh-huh.
And with such directionality?
Which one did you pick?
I think it's a fan. What is this? Dipole 80, 20, 10. What is the geometry? Ooh, we've got
I just saw it. It's a fan.
We've got lots of wires.
Yep.
I want to zoom in. I don't understand what it is that we're doing here.
Zoom at the bottom. There's a slider at the bottom of the screen.
I see it. It's right. Ooh, this thing's big.
You got multiple fans going on there.
This thing
and you've got currents.
Big.
If you
where's the current? Sorry. Yep. There we go. Yeah, we got. So we got two lines of current here.
Mm-hmm.
All right. And then we've got two lines of current here. All right. So we've always got two lines of current. All the way to the very end, or what's going on here?
How many actual? If you untick the box on the bottom there that says show current, yeah. So now you're looking at the wire itself.
It looks like it's folded.
Yeah. You got a folded dipole, and you've got multiple shorting bars across it. So it's really a folded fan dipole. So the little pixies, depending on their frequency, they can take different routes of their choosing. And electricity is always lazy. It wants to take the easiest path back to the source.
It wants to blow up a circuit trace real whatever's closest. Is this a loop, you think?
Yeah. Yep. Well, no, it isn't. It's a dipole. It's a fat dipole on one side.
Oh, we got a real fat radiator.
But it's got you see on the far right, there's a short. There's a DC short. So if it's a high frequency, let's say it's 28 megs, it'll take that path down the short back to the other side. It's a short. You're cutting
so
the
from this
it's really
corner,
not a loop because it's fed in the middle. There's an isolation in the middle. It's really a dipole, but it's a fan dipole.
I didn't mean to say a loop. I was just saying on this one radiating element. So is it just gonna it's gonna start it here? It's gonna equally travel to here.
Yep.
It's gonna see it as one element.
That's right.
Yeah, I got you. So we are running this on. People are blowing
it sloshes. It goes out. It goes to the far end, and it hits the end of it, and it says, "I can't go any further. I got to turn around." And when it says that, if it's cut to the right length, that's when it reverses direction electrically, not mechanically. Electrically, it's the other half of the cycle. You know what I used to tell people? Did you ever been on the at the amusement park, and you'd ride the whip?
The whip? No. What's the whip?
The whip was a chain-driven. You sit in a car with two or three. You have your girlfriend. You got her arm around her, and you're going down the. It's an oval, but it's a very elongated. It's like a. If you were a bird flying overhead, it's almost like a parallel. It's like a rectangle, okay, and the ends of it are half a circle. So the chain doesn't change its speed, but you're going down the center of it on one of the two parallel sides, and it feels exceedingly slow. You feel like you're doing 2 miles an hour. And then you go around that half a turn and wham, you get whipped right around. The chain is still moving at the same speed. The chain does not speed up, but because it has less area to go around, you accelerate around it, and your antenna is doing the same thing. The electrons are going down the wire, and they get to the end, and they all bunch up. And at that point, it changes its polarity. The signal that you're feeding it goes from plus to minus, and it pulls them. And it's just like the whip. They accelerate at the speed of light. That's an oversimplification. I know I've got engineers pulling their hair out going, "What are you talking about? You maniac."
I'll make sure
it's not that way at all.
I'll make sure to share it to all of them, right? Yeah.
The chat just went crazy.
Oh, yeah.
But if you're just learning it from, you're like my freshmen, my ninth graders, you can say that, and then they get a visual of what's going on. And then if they want to pursue it further, and you go to a double E class in college, then you learn the real math behind it. But it gets you a taste of, what's happening, why is it happening, and I think that's kind of cool. I think I might want to build a few antennas. You're accelerating the electrons. They're reaching the end, and they can't go any further, and they get whipped.
Is that right?
Yep.
Huh.
When if you see a cowboy with a leather whip, okay, or in some states it's a cowgirl. Ask Frank about that. And when you crack the whip, the sound it makes, it's making that sound because the end of the whip is exceeding the speed of sound.
Sure, yeah.
Okay, that's what actually makes the noise. It's breaking the sound barrier.
Yeah, it's
no different than a jet fighter.
It's
same deal.
It's let's see, in my brain, it's like matter and space that like got pulled apart collapsing back on itself again.
So
well,
your hand,
really, we're just playing with atmosphere, but
it's a good analogy because your hand can't move at the speed of sound. Okay.
right.
But if you crack the whip the right way, you go up slowly and then snap it back down, that wave energy that your hand is putting into the whip is a traveling wave. It's just like your coax. It goes down to the end, and as it gets to the end, it gets there. It has nowhere else to go. It has to speed up, and it speeds up to the point where it's faster than the speed of sound, and it makes that noise. Uh-oh, he left me alone.
I hear you.
I got the I thought you were taking off.
No, I was getting this.
Yeah.
No, I got my damn headphones loud enough. I could just set them on the table and hear you.
So it's kind of this. It's different. It's a mechanical thing. It's not electrical. It's not RF. But in really, really, really basics, you kind of every kid has had. They've gone to the circus. They maybe got a play whip or whatever. This is when I was a kid. Probably doesn't happen now, but it's something that we've all kind of experienced. So when you look at it and you go, and the antenna is kind of the same way. Yeah, it is. It's just you're applying electricity, a field into it, a force instead of your hand, instead of mechanics. I'm babbling.
I'm listening.
No, I know, but I'm babbling.
I'll take it.
Scope time.
Yeah, it's 200 megahertz is all I can get out of here, I think.
Mm-hmm.
All right. Well, fair enough. Do it. I guess it's doing it right now, probably, and I just don't even know. I told Ape that I was gonna keep this on the desk and learn how to use it. I'm a little intimidated because it is not a hand tech or a Rigol.
Right.
But it does have quite a few features, not only the voltmeter, but the function generator. So I'm going to start playing with the function generator in my antenna testing is my goal.
Cool.
Yeah. So I'm going to need some help with that. This thing, you actually have to almost abuse it to turn it off. I was listening to you.
Yeah. No, it's all good.
I was thinking to myself, I was like, how do I jazz up this so I don't look so boring? I was like, oh, I got it. I'll put an old Nintendo game on and connect it to my scopes.
Yeah. It's good to see the scopes.
So the Nintendo game, you'll love this, right?
Yeah.
So this is a NES, but it's not that NES. There's a smaller one. Sorry. There's a smaller one, and
right.
The CPU and picture processing unit were actually pulled from a donor motherboard, otherwise worthless, and were repurposed, rehoused in new circuitry, and it was a Kickstarter, and I waited over a year. I think it was close to 2 years for it. But it is.
Oh, I think I saw this on one of your streams. Yeah, you opened it. You showed the innards.
Oh no, that was the Raspberry Pi inside of a original NES shell.
Okay.
What we're seeing on the screen here is an actual NES processor running actual NES code in its raw. It's all original.
Wow.
Yeah, the rabbit hole goes so deep on this. I really hate it.
Yeah,
I really hate it. But I've all so that I could play this one game right here.
Mm-hmm.
Yeah, it was a Japanese game that American kids never saw.
Yeah,
and it is by far the most beautiful game that was ever produced on an 8-bit console. And yeah, it was actually part of a competition. and it was all Japanese kids. There was no American kids invited.
Wow.
Yeah, because you have to be like a robot with accuracy for this game. But yeah, it was. And in fact, they named it after the summer and the year of the event. It's called Summer Carnival 92.
So how did you learn about this game?
Anyway,
How were you introduced to this game?
through the nostalgia kick that I caught in my late 30s, because the Nintendo was not only my first gaming console, but apparently my mom says I went through 3 of them.
Wow.
I wore out. Yeah, I wore 2 slap out. So anyway, I spent a lot of time with this. And I was the only child in the country, so that's a big one.
Yeah. Yep.
Spent a lot of time on my Nintendo.
Yep.
So I mean, I don't even play it anymore. I just love the fact that it's running actual software on actual hardware in real time on a damn CRT.
Yeah. Wow.
Oh,
yeah. Cool.
Just can't. I'm sorry.
Yep.
I was looking at this fan dipole. So it says it did 80, 20. So there's the 10 meter, which we decided was a fat radiator. The 20 meter is self-explanatory. And then I want to look at the very end what he's done. Turn the currents off. He's boxed it again, it looks like, and it looks like there's a cut. I see a cut here, and I see a cut here. I do not see one here at the very end. Looks like he's done the fat radiator trick again. But anyway, so I'm going to run it on 10 meters. Yeah. And we'll try to wrap this up. So, how do you feel about this for 10 meters?
Terrible.
Okay, that's what I thought. What about this for 11 meters, though? Same question.
Oh, that's a winner.
Oh, isn't it? Isn't that crazy?
Yeah.
We've moved 1 megahertz, and now all of a sudden it's worth something.
So it'll radiate fine. It'll make contacts. It has a lot of energy going up into the sky because it's too long. It's
folding onto itself. Yeah.
Well, feed it if you do the fundamental. What is it? 80 is the bottom.
Let's do
that and see what it looks like.
Oh, it's perfect. Yeah, it's a perfect 80. Yeah. Womp. My word, that is a really broad 80 at the top. Oh, that's great. And then 20.
That's what my dipole looks like on 160.
Is that right?
It's just too low to the ground. Yeah.
So here's 20 meters. Ah, that's what it was. It was this particular fan dipole's got this, but this for 20 meters is absolutely worthless.
Well, that one part of it is, yeah. But the other 2 are great.
That's a lot, though. That's like half your power. No?
Well,
it's a lot of power. Okay,
Maybe
I'll go for a third. I'll go for a third. We got no purple.
But
very
again,
directional.
And I hear what you're saying, and you're right. But again, have you ever turned your power down when you're talking to somebody to see if they can still hear you? Like we do this all the time up here. So I'm running 100 watts. I'm talking to somebody. I'm like, hey, let me just for grins. let me turn my power down to about 5 watts. You know, I'm normally 10 over S9. I'm going to turn my power down to 5. Give me a signal reading. And they go, yeah, you know what? You're S7. I say, okay, let me turn it down further. Let me go down to 1 watt. Can you still hear me now? And they're like, yeah, now you're S6.
Oh, so yeah, you're fine. Full copy.
My point is, don't overthink it as far as looking at that pattern and going, oh, that's a crappy antenna because a third of my power is going straight up. You're still going to make great contacts with it. I mean, there are a lot of people that load up their gutters on their house. They're not resonant. They certainly don't aim the correct direction, and they still make a hell of a lot of contacts on them. The magic band, 6 meters.
You can
put when it's running, you can put a coat hanger out there and talk, and you'll talk over to Europe.
On 6 meters?
Well, maybe not. I exaggerate a little bit. For those of you who haven't been paying attention. But yeah, I mean, you know.
I long for my first 6 meter contact.
Yeah.
I go there. I basically just need to have a radio just on squelch 6 meters all the time.
Mm-hmm. Yeah. You know what I've had on squelch is the downlink from the space station on 2 meters.
Oh,
it's actually 440.
Oh, okay.
The downlink is.
Yeah. So you can hear that thing right when it did I tell you about my my 10 meter FT8 alarm clock?
No. Go ahead.
So my CB, right? So my 10 meter export.
Right.
I put it on 10 meter FT8 upper sideband, and I RF gain halfway, volume halfway, but at night you don't hear anything. Come around.
Oh, this is the alarm clock.
This is my alarm clock. Yeah, come around 6:30 somewhere. All of a sudden, just out of the blue, you'll hear. Somebody around here is making it.
Yep.
And then you'll wait 15 seconds, and then like you'll hear a little orchestra. There's a bunch more people, and like it'll wake me up in a heartbeat. Yep. And I love the fact that I wake up to the band opening on 10 meters during our solar cycle.
Right.
Because I can go to sleep with the squelch open because all you hear is just a nice warm sound
right
through the speaker, and it's actually very pleasant to fall asleep to. But yeah, 10 meters FT8 will work as a wonderful alarm clock if you're trying to get up, late for work.
Yeah.
Well, we're right on. It's 11:20, man.
I think I'm done.
I think I'm good.
Yep. Hey, this has been great. Thank you.
Hey.
Lots of fun.
We're going to do this again. Everybody, I appreciate y'all hanging out with us. Thank you, Hollywood. I'll check you later, brother.
Okay, anytime.
All right, man. See ya.